And I want to talk to you about what is called the discriminant. So let's read through what a discriminant is. It is the radicand, if you remember the radicand, it's the expression inside the radical of the quadratic formula. Think of it as a prophet. It's the thing, it's the piece that helps make a prediction about our solutions. So you should go ahead and write that down. Discriminant is this. It's the b squared minus 4ac. Notice each letter only shows up once. Notice I am not putting the radical. It's just the b squared minus 4ac. That's it. So the discriminant as a number can tell me about what types of solutions I have. So just by way of review, we've seen the number of solutions when we looked at graphs. So for example here, if I had a graph of a function that looked like this, how many solutions do I have?
2.
You have 2 because we call those solutions also the x-intercepts. So there are 2 solutions if the sketch looks like something like this. There is one solution if your sketch looks something like this. And again, the quadratic parabola could be opening up or opening down, it doesn't matter. But here we see it, the function parabola intersects at 1 point on the x-axis. And of course, our last option here, let me fix that, should say 0 or sometimes says no real solution. And that looks like this, where I have a graph that never crosses the x-axis. I have a graph that never crosses the x-axis. So because there is this gap right there, we don't have any real solutions. So let's talk about one other place we might see it is using square roots. And this will bring us right into the discriminant here. Notice that if I were to solve for x in this first problem, I would take the square root of both sides, and I would get plus or minus 2. So if your x squared is positive, we have 2 possible solutions. We have a positive version and a negative version. If your x squared is 0, if you take the square root of both sides, you get x equals 0. Notice that 0 cannot be positive nor negative. Because of that, if x is 0, then we have one solution. So it's in the same row as the one solution. But notice the problem here. If your x squared is less than 0, what happens? You get a negative inside. And because there's a negative inside, we say, we can't do that, which is not entirely true. We can't do that in the real world. So that brings us over here. If my discriminant is greater than 0, I'm going to have 2 real solutions. If my discriminant is equal to 0, it's as if my corresponding function is just barely touching the x-axis. So that'll give me 1 real solution. But if d is less than 0, that gives me no real solutions. So when asked the simple question, how many solutions does this have? Your answers are either 2, 1, or 0 / no real solution. So let's walk through a few examples together. The first one here, we do have to identify our a, b, and c. And I can do so in my head. And I am going to b squared minus 4ac. Since I'm using the discriminant, I'm going to write it down. A is 1, b is negative 3, and c is negative 4. So the d is equal to negative 3 squared minus 4 times 1 times negative 4. When you simplify this, I get 9 plus 16, and so d is equal to 25. Now, all we have to think about here is, since d is 25, that also means that d is greater than 0 So if I just look at my chart here, D being greater than 0, how many solutions do I have? The answer is I have 2 solutions. So I'm not going to box or circle anything I've written here. I'm going to box or circle this, 2 solutions. How many solutions does it have? This has 2 solutions. It's not asking you what the solutions are. It's just saying how many do you have? 2. So in the second case, we get b squared minus 4ac, and that simplifies to 30 minus 40. So since you get your d is negative 4, according to the chart, it says d is less than 0, so my conclusion here is no real solution. If you want to use this special r for real, that'll help you out to save a little bit of time, and I use SOL apostrophe n for solution. And for those of you who already started, some of you will notice this one here, that d is going to equal 6 squared minus 4 times 9 times 1. And before we attack, what's my small little mistake here, which doesn't affect anything, but can be important? Good, so I should have written it like this, even though in this case it doesn't matter. I want to practice paying very close attention to my negatives. So since d is equal to 0, my conclusion is that this has 1 solution. And there we go.